All right, number 9, we want to know on a certain subcommittee there's 5 senators, and then 3 of these are going to be appointed to make a subcommittee. We want to know how many possible subcommittees are there. So there's a couple of methods that I want to show you. One is expressed in this book, and one is not yet. It may show up later, but I'll show you that way as well. So first, they give us 5 members. These names, Anna Marie, we'll just use A, B, C, D, and E for each of their names. Okay, so we got A, B, C, just use the first letters. And we want to know how many subcommittees of 3 can we make. So one way you can do is by listing them. So we'll list all the subcommittees starting with the Anna Marie person and then a B. So we're going to do AB. So we're going to use these two, AB, and then we can use Carlos. We can do AB, D for Dean, and we can also do A, B, E for Ellen. Okay, so that's all the ones that we can use starting with AB. Okay, now we're going to shift over and do AC. So we'll say A, C, and then we'll use D for Dean, and then we can do A, C, and then we'll do E. Okay. So we're just going to continue to shift over. So now we're going to start A, D. Okay, so we'll start A, D, E. Okay, so these are all the subcommittees we can make using Anna Marie A first. Okay, there's 6 of them. So now we're going to start with B and just kind of shift over. Okay, so we're going to do B, C, D. Okay, and then we'll do B, C, E. Okay, so we did B, C, D, and then B, C, E. So everything we can do starting with B, C. So now we're going to shift over, and C, D, E will be the last. Well, we did B, C, D, B, C, E. Okay, and then we have C, D, E. I think we got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9. Seems as though something is missing. B, C, D, A, B, C, A, C, D, A, C, E, A, B, E. Okay, so then we do B, C, D, B, C, E. Okay, I didn't skip over. So B, D, E. I knew there should be 10. So I started with B, C, D, and B, C, E. We also have B, D, E. Okay, so B, D, E. Okay, so this is the listing method. There's 10 of them. However, there is another technique we can use. It is called combinations. It is if you have n objects and you want to select or choose x of them, r of them, it doesn't matter. There's a special formula, and I'll show you and I'll work it out for you. This is equal to n factorial, and then you subtract the 2, n minus x factorial, and then another x factorial. So this is that formula. With the numbers, we have 5 members, so n would be 5. We want to choose 3 of them. We want to make subcommittee of 3. So this will give us a count. Now, We don't have to list them. If you had to list them, then this is what you would want to do, all 10 of them. But if you just wanted to count them, you can use this method, and we'll plug in. So 5 is the end spot. We will have 5 factorial, and then on the bottom we would have 5 minus 3, so we can just put 2 factorial, and then we have another x, so 3 factorial. So we would do this, and this is how this works. So remember, 5 factorial, or anything factorial, just multiply each term down until you get to 1. So 5 times 4 times 3 times 2 times 1. On the bottom, we're going to have 2 times 1, and then another 3 times 2 times 1. So what will always happen is something from the top and the bottom will divide out. Okay, so those will just divide out. So we have 5 times 4, which is 20, divided by 2 times 1. So we have 20 over 2. 20 divided by 2, which gives us 10. So as you can see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this gives us 10 as well. This method is also in the calculator as well. So I'll show you how to do that, and then we'll move on. So in this calculator, I'm going to second quit, and I'm going to insert 5 first, and then if we go to math, arrow back to probability, you see option number 3, NCR. I used X, it doesn't matter. So we're going to do 3 for NCR, and then we wanted 3 for our second number. So if we do 5 NCR 3, it gives us 10. So there's 10 possible subcommittees that can be formed if we have 5 and we're choosing 3.